Hello, everyone. I hope now I'm audible, right? Ah, perfect. Ah, finally. So, the last talk of the Kubernetes Forum, Bangalore, I can see the faces. Everyone has gone to the containers, everyone has gone to the Kubernetes, inside the Kubernetes, outside of the Kubernetes. But this last talk is gonna be slightly above all this layer. It's okay. So, let's get started. I don't know how to remove this dynamic thinking. So, okay. So, I hope this doesn't mess up. Okay, fine. So, let's start with the introduction. So, my name is Hardik. I work for SAP since last 3.5 years. I've been part of the Kubernetes community also since 3.5 years. And I work for a project which is called Project Gardener. So, how many of you have heard of the term Project Gardener before? Okay, interesting. You're gonna have some cool stuff to know today. So before we get into the details, I would like to discuss something. I would like to ask a couple of questions. So, first of all, tell me, how many of you use only one large cluster and deploy everything on that one big cluster and then offer it to your customers? As expected, none of you. How many of you have tens of clusters, like 10 clusters, 20 clusters, 40 clusters? Still not many? How many of you have hundreds of clusters? Interesting. Okay, so irrespective of, unless you have one cluster and you are doing everything, which is probably not a best way of doing the Kubernetes. If you have many clusters, this talk is about you. So, as famously, this is from the movie called Inception. And Inception was one of the extremely mind-boggling movie. But don't worry, this talk is not going to be that mind-boggling. This is Inception. This is about the Inception, but Inception for the Kubernetes. And this is very famously known as Kubeception in the industry right now. So let's get started. I just prefer to start from the scratch. So a very simple Kubernetes cluster, what does it get? Brings you API server, scheduler, controller manager, etcd. And then you get work on the workers, you get kubeproxy, kubelets, and so on. This is a very simple structure. I like it. If I have to deal with more stuff, if I want highly available stuff, I would say, okay, I will bring more master machines, couple of more master machines, and then I would say, okay, I need more worker machines as well. And this brings us a good, happy Kubernetes cluster. I would be the happiest person in the world if I have to deal with only these things. One cluster and just do everything with that. But is that all we need actually? Most probably not. This is just the starting. I think this is when you play with Kubernetes, your day one is this. What really happens is that on day 2, day 3, you create more clusters for different landscapes, for testing. You're getting tens of clusters initially, then you're getting hundreds of clusters, and eventually, probably, if you have a much larger scale, you end up getting thousands of Kubernetes clusters. And that's where the whole ball game starts. So now you want to have these clusters, but you also want to manage a certain production quantities on top of them, right? I mean, for example, if you have so many clusters running, and on a fine day, you're sleeping or you're on vacation and one cluster's disk is corrupted, or Docker is hung in one of the cluster, or kubelet is not responding in one of the machine of in one of the clusters. So, I'm pretty sure I don't want to manually go there and do stuff. So what you would expect is some kind of automation. You would expect that everything should be taken care of. Now, Kubernetes is bringing a new era of managing applications, but there is something which is missing yet, is the management of the infrastructure itself, the management of how do you exactly manage the Kubernetes clusters itself. You would also probably want to have a nice auto-scaling, the disaster recovery, which is the biggest check mark in the industry. It said, if your entire region goes down, entire data center goes down, what will you do? You want a system which should be reliable enough, which should be bulletproof, it should be good enough to deal with all the problems. And then you would want to have monitoring, logging, and whatnot. So, of course, that brings a little bit of worry to us that maybe not now, maybe tomorrow, or maybe many of you have already started seeing it, that it's hard to manage many, many clusters, and there are so many different ways to manage the clusters that the ecosystem is already pretty fragmented. So let's first of all try to understand what do we exactly need when we have many clusters. So we understand the problem first, and then we will see how the solution should be. So I would say, from the experiences, I would want to have a universal Kubernetes clusters at scale, where my clusters should be completely homogeneous. So if I'm having a cluster across different clouds, I might have 10 clusters running on AWS, 10 clusters running on GCP, few clusters on-prem, on the private clouds, few on vSphere, on bare metals, whatnot. I would like to have homogeneous clusters across different clouds. I would like to make sure I'm using a very fundamental resources, which are standard Kubernetes resources like VMs, load balancers, and so on. I would like to also have a way to configure the operating system. I would not want to have a system, I would not make sure that I always run on CoreOS. You know what's happening to CoreOS. If you're following the trend, it's gonna be closed soon. So now the question is that I should have a system which supports multiple operating systems. I should have a system which can manage thousands of Kubernetes clusters, irrespective of what I'm doing today. If I'm managing only 100, it should have a fleet management system. Total cost of ownership should be as less as possible. When I say fleet management, it's basically, if I have an existing Kubernetes cluster, I would want that cluster to be managed as well by the orchestrator or by the system which I am bringing in. So now the question is that how we can exactly do that, and today's we're gonna talk about that how, and these are the modern problems, and modern problems, as very well said, requires modern solutions. So we know something interesting. We have a very important information that we sometimes ignore, is that Kubernetes is an amazing software for managing the application workload. If you have containerized workload, it's just amazing. It does the job so well. If we know this information, why cannot we not run Kubernetes via Kubernetes? Yeah, that's where the Inception part of it comes. That why cannot just not treat the Kubernetes as a yet another application on top of the Kubernetes? If it's a slightly mind-boggling, wait, you will see how it can actually be achieved. So rather than talking the theoretical details, what I will do is that I'll have a quick walkthrough from the very high level of an open source project which exactly implement the Kubeception model and which does exactly what we stated in the previous slides with the universal Kubernetes clusters as scale. So let's get into it. And we're going to talk about the Project Gardener. Project Gardener is basically an open source project from SAP. It has been a couple of years already, and it's basically from the high level, it helps you in having a reliable Kubernetes clusters as a service for you on the bare metals, on any of the public clouds, or the different clouds as well. Okay, so when I say the Kubeception, what I exactly meant. So let's get started. I would like to have some guesses as well from you guys, because it would be interesting to know for you too, that as always we have, let's assume we have one cluster which is a management cluster, this is basically, we call it a seed cluster, which has few master machines running and which has few worker machines running, which is perfectly fine. Now I want to use this cluster to create more cluster using an Inception model. Can any one of you guess how that could possibly be done? Any simple guesses? Okay, let me give you some hints. So for the worker clusters, what we basically need for the worker clusters, what is your Kubernetes cluster? So basically, your Kubernetes cluster is mainly your worker machines where you run your workload. You don't necessarily need to know what exactly your control plane is doing at any point in time. If your control plane is doing fine, if you know it's going to do what it's supposed to do, then most probably you will be only worried about your worker machines. You will only be worried that whether they have enough capacity, whether they can run your workload reliably or not. So that worker machines is what we call, it's fine. It's here. Okay, that worker machines we generally refer as a worker cluster. Now, this trend is not just a trend from a couple of guys, this is an industry trend. So in the Kubernetes community, if you're closely following, This is actually happening as part of the community where we are having a management cluster and we are trying to identify different potential approaches using which we can manage multiple other clusters. So the worker clusters here, as you can see, have worker machines, but where are their control planes? Any guesses now? So you can see I have one cluster already running well, and I have already a worker machines for the worker clusters. So as expected, as intuitive it could be, is that the worker cluster's control plane basically runs inside the management cluster, probably just as a new namespace. So what is the control plane? Let's go deeper. So your control plane actually is nothing but a set of pods, right? They are just set of controllers running somewhere. And now it's up to you how you want to manage those controllers. Either you can bind them on the machines and say, this machine is my control plane machine, or you can also be simply saying that these are just yet another pods and they are going to run as a workload of yet another cluster. So now you are seeing that this one worker machine, which would have previously taken only one control plane on it, can now manage multiple deployments of multiple worker clusters. And that model is what we refer as a Kubeception model, where we run one Kubernetes cluster, this Kubernetes cluster on the management cluster, which is again the Kubernetes again. So this Kubernetes cluster is basically using the standard Kubernetes primitives like deployments, replica sets, load balancers, and everything, which is battle tested. You know it's going to work. It's not going to fail. Now, we discussed one part of the solution only yet. We talked about the universal statement that we talked about is too broad. So in this case also, if you see, there is still a possibility that one of the worker machine can still get unhealthy, and I would like to have auto-healing or self-healing on its own. It's still not covered here, right? And I might want to have the auto-scaling of each and every different worker pools running in different clusters and so on. So that brings us to second very interesting trend which is happening in the cluster, which is happening in the Kubernetes community itself as one of the sub-projects as well. So cluster API. Have you heard the term cluster API? How many of you have heard the term cluster API before? Okay, interesting. So the cluster API and the machine API are a very interesting way of managing the infrastructure resources. So we just discussed some time back that how pod works, right? You create a pod and then there is a kubelet running somewhere which fetches the pod. It was all amazing. We know that it works for the Kubernetes, and why can we not do the same thing for the clusters as well? So if you can create a pod.yaml and expect a controller to create a container for you, you can also create a cluster.yaml, or we internally call a shoot.yaml. You create basically a cluster.yaml, give all the necessary information inside it, what domain it's for, what infrastructure it needs to run on, what Kubernetes version you want on it, and stuff like that. And if you can implement a controller which can understand this information and do the necessary job for you, basically you are bringing the entire imperative way of managing clusters from one era to the other era, which is a declarative way of managing clusters. So for tomorrow, if you want to create 10 clusters, you would only be creating 10 different shoot.yamls or cluster.yamls, and the controllers will do the job. In a similar way, the second part of the game is the machines.yaml, where the machine API kicks in, where right now community is also trying to define or align on a spec of the machine that what could be a universal way of identifying a machine object. So in the machine, as we said for the cluster, you can have a machine object where you mention the machine image, the type of the machines and so on. And you basically give this information to some cluster orchestrator, which could be Gardener or which could be what is being developed in the community or somewhere else. You provide this information to a cluster orchestrator, and that orchestrator basically interfaces the information to the real cloud or on-prem, and you at the end of the day, you get your cluster running. That's a high-level idea. That's the second part of the solution for the big problem that we talked about. But that's not actually all. We have covered the technical aspects very well. Now we know that with the Kubeception model, we can manage many clusters control plane altogether. We have made sure that our infrastructure is going to be very well taken care of so far. But the third thing is more important. In the morning, I guess there was a very good discussions about the extensions mechanism in Kubernetes, right? So what is the extension mechanisms basically? So you can think of it in a way that you have a certain things running very well on a certain cloud with certain environment, but that's not all you want. If you want a larger or community adoption, if you want people to customize your software, you need to be able to swap each and every component that you have developed. So if I write a software which runs well on AWS, I should be writing it in a way that it should work exactly in a similar way on GCP as well. So I should be able to write good extensions for that, right? In a similar way, if the given environment works well for Calico or CoreOS, there should be a good extension model which can simply swap Calico with Flannel, maybe CoreOS with Ubuntu or whatnot. These are just some examples. And that's where the power of the extensions comes. So the bottom line is that three key things: Inception model, plug-and-play mechanisms, and cluster API and machine API. If you can combine these three amazing part of the solutions, then you get the next generation features for your clusters. So you would not have a time where your hundreds of clusters running somewhere, where something is going down, something unexpected is happening, and you have to immediately go there and fix it manually. Those days are now gone. I would expect that we understand that, because everything can fail. That was also told in the previous talks. You have to come with the assumption that everything we build is always going to fail, and our system should be reliable enough to fix them on their own. It should be a complete automation. So what are these next generation features we are then talking about? So let's take a look. I have one cluster, let's say, created with 3 worker machines, and it's being managed by the cluster orchestrator. Now from these 3 worker machines, as I said, if any of the worker machines, Docker is, let's say, hung, or if any of the worker machines is gone out of the blue, this happens sometimes in the on-premise, right? Then it should just be replaced on its own. If there is a very high load on my clusters, if there are 3 worker machines and if I see that there are many pods which are not getting scheduled because 3 machines are not enough, then I should have a good auto-scaling which automatically scales it up in a similar way. I should have a good downscaling as well, where it should scale back to save the resources. And eventually with Gardener, we also implemented an interesting feature of the rolling updates. Now, what can be achieved, what new things can be achieved comes here. So far we know that we have always been seeing an infrastructure and the application layer of the Kubernetes as 2 different layers. But if you follow the best practices, then what you can do is just too good. Why? Because let's say you have an application running with certain version on given Kubernetes cluster, and now you have set up some PDBs on it, some SLAs set up on that, and you're saying I have 5 instances running. At any point in time, not more than 2 instances should go down. That's my SLA to be maintained. And then you hit the security patch. Some bug is found, and you get the information from top that all the machines has to be rolled out. How do you reliably do that? This is actually a very complicated problem. So you cannot just go ahead and turn down all the machine and turn on all the machines again. I don't think that's a great way of doing it. Neither you can just create so many new machines on one hand and then try to migrate all the applications from one place to another place. In that case also you will end up messing up with your SLAs. So here, when we talked about machine API, we have implemented something called machine deployment. So if you know the pod, you must know pod, replica set, and deployment model, right? How deployment does this thing so nicely with the pods? You must have tried to upgrade your application via the deployment controller of the Kubernetes, right? From version 1 to version 2. Just imagine you can do the same thing with your machine. So when machines, let's say, are running some version of operating system or Kubernetes, which is, let's say, 1.11 or 1.12, and now I trigger an upgrade. So with the upgrade, all these machines are going to be swept one by one, making sure that if there are 5 machines, if I will bring down the first machine, that's going to break the SLA. So I will not bring down the first machine. I will bring down the second machine first. I will migrate the workload of the second machine. Then I will bring down the third machine, and so on. So those kind of very intelligent logic then can be built upon if we have a good machine API and cluster API aspects implemented. And then, of course, the cost saving. We see this very often that when we run many clusters, we know that we don't want to keep them running all the time. So many clusters are created by developers and they are just for playing around, not always used. So many clusters are just not required to be run all the time. Then we implement the stuff like hibernation, where all the worker machines are simply brought down. You can just bring down your deployment of your control plane and you save a lot of cost. Here, you also see that this cluster orchestrators does not really necessarily be connected to your worker machines all the time. If there is a connectivity issue in between, then Gartner simply assumes, or the deployments are done in a way that even if there is a connection issue, this guy will work fully functional on its own. So availability should not have unnecessary dependencies on each other. And last but not least, is a very important part where your clusters should be properly backed up. Because as I said, everything can fail. So if your HCD is running on certain set of volumes, you may say, I have 3 HCD instances running, but it is very likely to be possible that your volumes of all of the HCD volumes are simultaneously corrupted or whatnot. So you should have a good backup and restore mechanisms done, where in case everything is gone, your HCD backups are continuously stored into the cloud. Any of the cloud store, could be S3 or any other object store, and it can be backed up, it can be restored immediately, and then you get your Kubernetes cluster back soon with a very minimum loss of data. So that's what we overall do. We basically implement such aspects very properly in the project. It's called Project Gartner. There's a link, you can just simply go to the link and know more about it. And we also have an open community where we discuss the issues on the Slack all the time. So I'll quickly show a small demo. Okay, so I'm connected to the internet today, and okay, this is a dashboard for Project Gartner, and as you see, there are many clusters already created, few are already running and reconciling, and few are already in the hibernate state. So in today's demo, I want to show something more than what you have seen. So I can simply click on the create button, and you see, as I said, there are many extensions available. So we have created the extension of all different clouds. These are big 4 clouds: OpenStack, Ali Cloud, then vSphere, and so on. But we have also added a support for a Metal. So Metal is basically a bare metal provider in Europe. So you can think of it in a way that there is, as this project is open source, in a European company called FITS, they took up the project and they do everything on the bare metal machines. So they created a plugin, or they created the extension which was added into the Gartner, and now Gartner can create the clusters on the bare metal machines, which means when you need to create a machine, you actually boot up a real bare metal machine, and you actually stop the real bare metal machine when you want to stop the cluster. So in the creation, you can see that you give a very basic minimal information of what are your cluster details. You give a name, what is the version of it, the purpose of it, the infrastructure related details, which could be any of the provider ID, the worker pool information, which is again about something where you don't want to have heterogeneous machines running on your cluster all the time. You want to somehow manage them in an automated way, where you tell that for a given worker pool, my minimum of the replica is 1, let's say, and maximum of the replica is 5. So whenever the load increases, make it 5. And whenever the load is not there, just make it 1 again. And you can add multiple worker pools as well. In a similar way, you can add the add-ons in it. You can have a maintenance time window, as we discussed about the security patches, right? So if security patch is rolled, there should be an option to the user where user can say that only during this time period, the operating system patches should be rolled to my cluster, because other point in time I would not like it to be rolled, or the Kubernetes patch version, whether it should be rolled automatically or at what time it should be rolled. So this maintenance time windows can now be configured, and at the end the hibernation can also be set. So I would not create the cluster, it will take a couple of minutes, but I have already created a cluster for us, which is called a Metal cluster. And with the Metal cluster, as you can see, all the information that we provided there is more or less populated here. On top, I mentioned about the monitoring, the audit logging, and so on. So very likely when you manage many clusters, you don't want to manage all these things manually with different clusters, right? So with the automation like Gartner, all these things are installed on each and every cluster. If you want, you can opt out, or you can opt in separately. So in the monitoring, we simply install a couple of things. Logging, Kibana already gets installed, and the normal other configurations of the clusters. And not just that, UI is good to have, but at the end of the day, we deal with YAMLs. So at the end of the day, you can also just go to the shoot YAML or the cluster YAML in general terms. You can modify any of the fields of the shoot YAML, and then the backend reconciliation looks at it. If I modify any of the networking information or any of the machine type information, workload informations, then the backend reconciliation can look at it quickly. It will try to match the desired state with the state which is resulted with the real world state in the backend, and when both the states are matched, you will get to know on the dashboard. So that's more or less what I have. And okay. With that, I would say thank you. And if there are any questions, we have last 2 minutes left to discuss the questions for the same. Okay, then thank you so much, guys, for joining, and have a nice day ahead.